Hello everyone, in this video we are going to model a cable for Ibwave design using the DB editor. We are going to use a Heliax cable from Andrew Comscope as an example, and let's have a quick look on its specifications. So it's a 1 and 5 by 8 inch cable. It has a 50 ohm impedance and maximum peak power of 315 kilowatts. There we can also find the long list of the attenuation per 100 meter or per 100 feet for its frequency range. So let's add a new part. We select the type to be a cable. Then the properties list will be populated. There are actually few mandatory parameters that have an impact on link budget calculations, such as the length or the loss, while other parameters are just there for info. The manufacturer should be Andrew, and we can copy the model from the spec sheet. Okay, now we need to write a short description about this part. I will use this sentence here. So it's a Heliax flexible coaxial cable, smooth wall aluminum, 1 and 5 by 8 inch of diameter and black jacket. We need now to use a design image for this cable. We can also copy this spec sheet image. Hit a print screen button on the keyboard and use a user-friendly photo editing tool like a pen.net. Just selecting the cable image, crop this selection and save. I'll save it to my desktop and give it a reasonable name, like cable from Andrew, and it's Heliax. We choose the format to be GIF for economic reasons. Okay. Now we can use this image in the DB editor.
Layout image is not needed because cables are represented by trace.
And then we can start filling in the properties. We should fill in the trace width to be 8 as the standard size of 1 and 5 by 8 inch. And the type of media should be coaxial. Now we can fill in these parameters from the PDF sheet. The length can be 1 meter as read-write,
because it shall be calculated according to the actual rules on layout plans, while fixed length jumper should have read-only mode with cost unit set to dollars instead of dollars per meter.
The outer conductor is a smooth wall aluminum. The inner conductor is copper. Diameter over jacket is 50.292, and so on. The minimum bending radius can be found also on the spec sheet, 279.4 millimeters. We choose an Andrews connector for the source side and mobile side. And we keep the jumper field blank. Now moving on to the coaxial properties, we found out that this is a 50 ohm impedance cable. The maximum frequency is 2.7 gigahertz. The velocity percentage is 88. And it has a 315 kilowatt of maximum peak power. Now we can hide this parameter as we are not going to use it. We could also hide the optical parameters and twisted pair parameters as well. Now we should fill in the loss for each band per 100 meters. So we add a new band
by doing a right click.
We fill in the start frequency that we can look at it in the datasheet. It's from 0.5 megahertz with 0.042 dB per 100 meter loss. The next frequency range is 1 megahertz. The loss is 0.042 dB per 100 meter. Now we should add another band to fill in the next frequency range. It's at 1 megahertz up to 1.5 megahertz, the 0.06 dB per 100 meter of attenuation, and so on until we fill in the full list. As shown, the full attenuation lists has been populated, and now the cable is ready to be used within Ibwave design environment. Now let's save our database. So going to File, Save. If Ibwave design application is already open, we have also to update database from Tools menu, because only afterwards the updated or saved database can be used. Okay, so now let's create a new project just to verify our modeled cable. I'll drop a GSM 900 MHz system. And we'll select a base station sector type with 33 dBm of output power per channel. Okay, let's also drop an Andrew Cellmax antenna. And use our modeled cable to connect between them. So it's FXL minus 1873. Okay. Good. Now let's assume that this is a 100-meter cable for easy verification. So the length will be 100 meters. Okay, and let's just enable the cable loss calculations for this system. So now we can see that this cable has a minus 2.2 of attenuation for this band. If you look at the datasheet, it should be minus 2.09. However, if we consider the connector losses, we should come up with the same result. So let's do it. From project properties, calculations, general, and we uncheck connectors, validations, and calculations. Okay, now we exactly see the datasheet specified attenuation for this frequency range. Well, that's it. Thanks for your time.